Chapter 6, doubling time, etc. Here's an interesting formula. We can derive the exponential growth rate R sub B is ln of 2 over time to double. This can make it easier to set up a model. Suppose, for instance, we have an initial population infected at 25. Time to double is 3 days. So, for instance, in 3 days we'd have 50. 6 days we'd have 100, 9 days we'd have 200, etc., etc., etc. Sometimes we know that. If we can track infections, in the early days of COVID back in February, every 3 days a population was doubling. So this was the rate, not necessarily the rate of infection, but at least the rate of tested infections. So that didn't necessarily follow the rate of infection because not everybody was getting tested. So time to double, RE is equal to ln 2 over 3. And you can do that on a calculator. It gives you 0.231. And so our model, quite simply, is I of t is 25 e to the 0.231 t. And as this population is very small relative, this initial infected population is smaller relative to the overall infectable or susceptible population, of course, we could go further. Assuming we knew K, we could set up the logistic model using this growth rate as an estimation. This is approximately equal to RL, and that's assuming I0 is less than K, remember, so we could do that. So that's all there is to this video. We'll be back with Chapter 7 shortly.